I'm not a cryptographer, I'm an expert in Gröbner bases, and I have to explain the title. What does it mean, hope never dies? The origin, well, there was a classical paper on Gröbner basis in cryptography by these authors. Hubert E is a dog, Descartes Kahn, he writes right to left, Julia X is Hubert E. Theomoriatry is the mortal enemy of Sherlock Holmes, you know. Yes. And L3 is anonymous. And as you can see on the bottom, it is supported by specs. This is a paper of the Journal Symbolic Competition 14 years ago. And while you cannot even hope to use Gröbner basis in public key cryptography, an open letter to a scientist to fail, and the challenges to those who have not failed, yet failed. How is it? No? So, in the last 14 years, several scientists have failed, beginning with Pelos and Kobitz. They have defined the polycracker tensor system, which are a special case of these, and none of them has survived. Yes. Now we are trying to fail, and we propose two new public key crypto systems that use Gröbner basis for the key definition. Okay. These two crypto systems combine polynomial algebra and lattices and modify two well-known crypto systems, which are GGH of Gröbner, Vassar-Levy, and L2. And both modifications change the key creation and the decryption, but the encryption remains the same. Well, I say a few words about the first one, but just half a minute probably, since it is too technical. The key point is that lattices are the same thing as ideals generated by binomials, difference of two monomials, and the vector corresponds to the monomial in this way. It is very technical construction, and the resulting crypto system is a variation of GGH. It is also a polycracker crypto system. The difference between GGH and this new crypto system is that instead of decrypting doing Bye-bye round-off algorithm, one uses Gröbner reduction. And the problem is the concealing of the private key. And these are problems we hope to be able to have been able to design it securely, but it is not sure. And the other is modification of L2, and we will spend a little more time about this. I lost the time, so I don't know how much I had, but I hope in this, the difference are the differences. Here are the two differences, the difference between L2 and GB L2. The difference is mainly that you have something uppercase and something lowercase, but the key difference is that when you make the inverse of F in the creation of the private key, you make it through a private ideal, not a public information, but it is private information. And to decipher, there is a problem at some point. Instead of what one does in N2, there is an extra step in which we have to make substantially to find the closest vector to a lattice. And this one practically is the case if the lattice is both. Well, avoiding the attack, the key.
You're very cruel about this, but I'm going to fire you off the station, so I'm just talking.